Okay? Complex fractions are fractions inside of a fraction. This is just another way to write a complex fraction. Okay? If I, instead of writing it with this division symbol right here, I could have taken this whole fraction here, divided by, and if I just put this whole thing down here, that is the complex fraction that we're going to be looking at today. So the process of working through this is no different than what we're going to be doing today. Right, and so the idea here is when you are looking to divide, what you're simply going to do is you're going to convert it into a multiplication, and dividing is equivalent to multiplying by the reciprocal. So what we're going to do is we're going to factor each of these completely. Okay? Now it's up to you how you choose to factor it. The leading coefficients of 1 are easy to factor. Okay? The binomials are first terms x's, the second terms are the factors of -8, whose sum is a +2. So what would that be in this case? Plus 4 minus 2. Okay? Here's my other leading coefficient of 1, so I'm going to factor that just by reverse foiling. The two factors of +16, whose sum is +8, plus 4, and plus 4. Okay? Now, once you do the ones that are easy for you to do, now you can move to the ones that are a little bit tougher. And again, trial and error is probably a very easy one to do for this. And when you get familiar with it, you can see the leading coefficient and the constant are both prime numbers. There's only one pair of factors that give you 2's. So this is going to be a 2x and an x. Since the last term is positive, you know the signs of your middle term, or your last terms here in each of these binomials has to be the same. And since the outer plus inner, again, if you're doing trial and error here, is negative, you know that these have to be negatives. Right? And then the only two possible factors that give you a +2 are 1 and 2, or 2 and 1. Now, let me talk about why you don't even have to test both of these. And the reason is, if you looked at this second combination right here, 2x minus 2. If that was the correct combination, notice that you could have removed a common factor of 2 from that, right? It would be 2 times the quantity x minus 1. Can you remove a factor of 2 in this original form? No. So you know that that can't even be the right combination. So not only do you only have to test for 2, but one of them is inconsistent, so you know that this is your solution. Now, you can test it to see when you take your outer and inner products. You get -4x minus 1x does give you your sum of -5x. And so that is your solution. And then if we come up to this one, again, we have a prime number as our leading coefficient, but our constant has some different possibilities. It's still pretty easy. You know that your possible factors are, I'll write it up here, 2x and x for the first term. Okay, when you're looking at the reverse FOIL, you know that the last term is positive with the outer and inner sum being positive, so these two signs both have to be positive. So really all you're looking at is testing the combinations of 1 and 4, 4 and 1, or 2 and 2. Those are the only combinations you need to check. Okay? And once again, if you go through that same little test, okay, you can eliminate some, because when I look at this second one, 2x plus 4, if that was the factor that I wound up with, then that means that you would be able to take a factor of 2 out of both those terms, which means you'd have to be able to take a factor of 2 out of all of these. Is that possible here? No. So this isn't going to work. And then the 2x plus 2 fits that same pattern, right? If that was going to be the ending factors, then you would have been able to take a 2 out of the original, which can't happen. So you're left with the only possibility, which you can test. 2x plus 4 is 8x, plus 1x does give you your middle term, 9x. Okay, so once you get this all factored, what we're now going to do is we're going to invert and multiply. So you get 2x plus 1 times x plus 4 all over x plus 4 times x minus 2. We're going to invert and multiply. The x plus 4 times x plus 4 gets moved to our denominator, and the 2x minus 1 times x minus 2 gets moved to the numerator. Okay, once we do that, we can cancel any common factors. X plus 4's cancel, x minus 2's cancel. That's it. So our answer is going to be 2x plus 1, just leave it as factors, times 2x minus 1. all over x plus 4 squared, or x plus 4 times x plus 4. Either of those is fine. Okay. Now, this is all you have to do for this answer because it doesn't give you any of the additional domain restrictions, but I'm going to talk about that anyway because this came up in some of the other problems. Okay, so the additional domain restrictions means the ones that aren't apparent in the simplified form. Okay, in this simplified form, you know that x equals -4 is a vertical asymptote. Okay, so that's the one that's apparent. What you want to do is you want to find the additional ones, the ones that are no longer apparent in that simplified form. And the way you're going to do that is if you go back and you look at your work, because you inverted and multiplied, it adds sort of an additional layer of domain restriction here. Okay, but what you're going to look for here is any of the factors that got canceled in the denominator that are no longer apparent. So here we see that x can't be a -4, and here we see x can't be a 2. Are either of those still apparent in the simplified form? Yeah, we see that x can't be a -4, right? So we can disregard that. That one's still apparent. But the x can't be 2. We don't see that in our simplified form. So that is one of our additional domain restrictions. That means there's going to be a hole in the graph when we start to graph these at x equals 2. And remember, again, if we were, or when the time comes that we're finding the holes, it's going to be at 2 and then f of 2. Those are that's the set of coordinates that you're going to have for that hole. Okay. Now, there is, because this is a division problem, and there is an additional domain restriction that you need to identify, and that is any uncanceled factors that were originally in the denominator of the fraction. So notice here, this expression right here, 2x minus, or this factor 2x minus 1, originally was in the denominator of its own fraction, so that can't be a 0. That's no longer apparent in the simplified form, so we see here that x can't be a positive 1/2. Since that's not apparent in the simplified form, you have to include that as well. So those would be your two additional domain restrictions for this problem.